All right, let's start inequalities. So an inequality is used, so we're going to say is used to compare values when they are not equal. So I'm sure you're familiar with what they are. They're when we use these symbols. Okay. So whenever we use any of those four symbols in a math equation, well, math inequality, it's not an equation, then we're comparing. All right. So let's write down what each of them are and what they represent. Okay. So the first one is less than. Is less than. And you do need the word is in front of it when we're referring just to the symbol. So the symbol is this one. Okay. And a typical way of writing, using it in an everyday sentence, is just saying less than. Less than. Okay. Make this a little longer, maybe to there, because the others are going to have a couple more expressions. All right. So that is less than. Then we have is greater than. Is greater than. And that's this symbol. And for that, we use an everyday sentence that could be used is saying more than. There's others, but this is the most popular. You know, the target is more than 100 feet away. What else do we have? Anybody know? We have is less than, is greater than, the equal to ones. We got the equal to ones. Which are actually more useful. So we have is less than or equal to. And that would be the less than symbol with that little bar underneath. And a couple of ways we could say this is at most. I have at most $200 in the bank. That means I have $200 or less. Another one is no more than. So if you ever use no more than, you're saying that amount or less. The hospital is no more than 5 miles away. So it's 5 miles or less. Let's see here. What's the last one? We have is less than, is greater than, is less than or equal to, is greater than or equal to. Is greater than or equal to. And that one would be a greater than symbol and a bar underneath. And all we have to do is reverse these sentences or these phrases, and we have the common phrases. So what's the reverse of at least? Oh, I'm sorry. I just said. What's the reverse of at most? At least. Sometimes it's in my head and I don't. Ah. And then what's the reverse of no more than? No more than. Just change the word more with less. No less than. I have no less than $100 in my pocket. That means I got $100 or more. Okay. All right. Now there's an interesting fact or phenomenon with inequalities. Every inequality can be written in two different ways. Okay, so let me give you a for example. Every inequality can be written two different ways. I'm going to give you a couple of examples. Okay, example number one. I'm just going to write an inequality that's true. 9, then this symbol, then 4. So that's 9 is greater than 4. That's true, right? Yeah. Or take this inequality and flip it. Flip the inequality, turn it around so that 4 starts the math sentence. So if I do that, 4, but now I flipped it, right? So what happened to my inequality symbol? It's no longer greater than, it's less than 9. Okay? Is that true? All we did is a flip. And sometimes it's going to be important to do that. View it in its other way. It's kind of like a reciprocal. Okay. Another one with a variable. Let's say I have -9 is less than or equal to k. Okay, we're going to be looking at inequalities with variables in a little bit. So write that down. That's one way to say this. Or let's flip it. We're going to give it a flip. Turn it over like a pancake. So what's it going to start with, -9 or k if I flip it? It's going to start with k. The inequality is no longer going to be less than or equal to. It's going to be greater than or equal to, and then -9. Okay? All we did is turn it over, look at it a different way. But here's the thing. We're going to be graphing these inequalities on a number line. And the way you want to view it is this way. with a variable first on the left. So there's a method to this. If you see it this way, we're going to flip it. We're going to want to see it that way. It's going to be easier to graph. Okay? So let's go ahead and start graphing. So we're going to graph the inequality. Okay? So we'll do 4 of these. Let's see here. Let's start with this. Number 1. T is greater than -1. Let's write that down. T is greater than -1. Do you remember doing this, making a number line graph, maybe last year? It'll come to you. I'm sure you did. You'd be surprised. Okay, so first off, we're going to make a number line. And since this one's close to 0, I'm going to center it around 0. You don't have to. If you get a number like 4,000, you don't want to have 0 in the middle. You want to have maybe 4,000 in the middle. But I'm going to make my number line with 0 in the middle. Oops. Started off with, this is the positive side. Okay, +1, +2, +3. Okay, I want -1. Now, so everything happens in and around -1. Do you remember doing this where you made a dot and then shaded one or the other side? I want to show that all the numbers that are true. What numbers can I replace T with that would make this true? So can I say -1 is greater than -1? Nope. Can I say 0 is greater than -1? This is false. This is true. Can I say 1 is greater than -1? Yeah. So this would be true. This would be true. Can I say 80 is greater than -1? I know it's not on the number line, but could I say that?
Yeah.
Yeah. So basically, all the numbers greater than -1 are to the right. So I'm going to show it this way. At -1, I'm going to make an open point, like a circle. Does that sound familiar from last year? Mm-hmm. And then I'm going to shade in everything to the right. And if you think about it, look at your inequality. Your variable's on the left. Do you see that it's pointing this way, your inequality symbol? It's directing you to shade this side. So all the answers to this math expression is anything bigger than -1. And this is how we would show it. On to infinity, anything going that way would be, huh? Well, T could be any of those numbers.
Any number bigger than -1.
Any number bigger than -1. This is how you show it on the number line. Okay? All right. So let's do another one. Number 2. Let's do one with an equal to. So let's do M is less than or equal to, let's say, 20. That number is a little too big for 0 to be included. So I'm not going to include 0. Okay? So I'm just going to center this around 20. That's kind of the number of interest. Okay? And then this is 21, 22, on to infinity. And then the number is lesser than that. 19, 18, 17, on to negative infinity. Now, we want all the numbers 20 or smaller. So can 20 be one of the answers? Is 20 less than or equal to 20? It's equal to, so that qualifies it. So that means we don't put an open point like a circle, we put a dot, a big old dot. And then which side are we going to shade, the left side or the right side? Where are all the numbers smaller than left side? No, everything this way. All the numbers that would make m true are on the left side. Okay? So do you notice our variables on the left and our inequality symbol, this guy, is it pointing left or is it pointing right? How would you say it's pointing, the symbol? Left or right? Right. Well, this symbol right here, I see it pointing that way. I see it pointing left. Like this one, for the first one, I see it pointing to the right. So that's one of the reasons I like having the variable on the left. Okay? Let's make another one. I'll see if I could fit it in here. Number 3. Let's do n is less than 14. Okay? I'm going to try to squeeze in another number line here. It's kind of far away from 0, so I'm going to put 14 here. 15, 16, and then 13, 12, 11. So let's see. Is 14 part of our answers? Can I say 14 is less than 14?
No.
So that's going to be another open point. So whenever you don't have that little bar, it's an open circle. When you don't have the bar underneath, it's an open circle. Now, which side are we shading? Left or right? Left. We want all the numbers smaller than. Okay? Okay. You think you got that? Easy enough? All right. Let's do the reverse. For the next examples, I'm going to give you the graph and you're going to write the inequality. Okay? You ready for that? Let's try it out. So what we're going to do in the next part is we're going to write the inequality from the graph. Write the inequality from the graph. So that's going to be something like this. Let's say I give you this inequality. Let's all draw this inequality. Zero, 1, 2, 3, -1, -2, -3. And we're going to do this. A closed point right there. And everything in this direction. Okay? So we're going to write the inequality. So let's say we have x as our variable. And let's go back at the ones we've already done. X is blank to -1. Obviously, -1 is the main actor in the show, so it goes there. What kind of symbol do we want?
Greater than.
Greater than.
Greater than.
It's greater than because it's everything to the right. Does it have an equal to part? Do we put the bar underneath?
No.
How can we tell if it's a yes or a no? I'll give you a hint. It has to do with the point. Is it open or closed? So with the closed, we do need the bar underneath. It's x is greater than or equal to -1. And the reason it's closed is because of this. It's closed. Yes. Well, that's how the graph is. They're going to give you a graph, and you have to write the inequality. Okay? Well, the graph will tell you. The next one's going to be an open point, so it's either going to be less than or greater than without the equal to. Okay? What else? The other thing I want you to do, give this inequality a flip. Turn it over. How would I write it then? Let's see. -1 is going to go first. Less than or equal to x. So if I flip it over, that's what either one of those is a correct answer. Okay? Either one of those is a correct answer. Any questions? Okay, let's do a couple more. Number 2. Let's do a number line on the negative side. We're centering this one on -20. Okay? Okay, so this time we're going to do open point here. Make sure you put an open point and everything to the left. So we're going to use x as our variable because on the IXL you have to use x as the variable. So first of all, it's an open point. Open point. So do we have the bar underneath? No, we don't have the bar underneath because it's an open point. Now, it's either less than or greater than. Look which side it's shading. It's shading to the left, so that's less than. -20. So I'd like you to flip it and write the other possible answer. What's the other possible answer? Turn it over like a pancake. -20 would go first. -20 is, which symbol do we want? Greater than x. It's as if you were flip it over, everything switches around. Okay? Couple more. So the next two, I'd like you to write it yourself. Work with your partner. All right. Okay. Here's 0. Here's 1. This is right in between. Okay, so here's the next one, guys. And I'm going to do number 4 to finish this off. Start thinking about that one while I do the last one. All right. So use what you know. Check in with your partner, see if you both agree, and write down these two. And then flip it around and write the other possible solution. So start with X and then decide what it should be. Okay. Here. So please help me out. Do we have equal to bar underneath? Yes or no?
Yes.
Is it greater than or less than?
Greater than.
So it's greater than or equal to with a bar. What number? What number is that?
0.5.
0.5 or 1/2. Okay, now let's flip it over. If I flip it, this is 0.5 is less than or equal to X. Okay, let's do the last one. Do we need the bar underneath? Do we? No. Which inequality, less than or greater than?
Greater than.
And that's negative 29. Okay, let's flip this over. Okay, so now we have negative 29 is less than X. Okay. All right, so this is it for the notes. There's two IXLs. One where you're going to be given the graph and then you're going to make the inequality, and one where they give you the inequality and you're going to make the graph. Okay, so let's get to it.